We're at gotomath.com and we are working under calculus here, working some related rate problems. This particular one is coming from this section, and we're going to be working a problem like this, except a few numbers are going to be different here. So let me just click over to it. It says find the rate of change of the distance between the point 3, 2 and a moving point on the graph of y is equal to the square root of x plus 3 when x equals 7 centimeters and dx over dt equals 4 centimeters per second. And then we'll round our answer to 2 decimal places. Alright, so let's move over to the whiteboard. So I believe I've got 3 of these problems right now for the moment in that section 4, that button that you click on. This graph right here, just kind of draw a picture of what we're looking at, and I guess I'll use this color here. And so we got this, whoa, that's, okay, just a second. Let me first, let's first do this. The, right, so the curve is going to be defined by this guy right here, and I'm not going to write this with a square root. We'll just write it like that, and we got to take the derivative of this here in a minute. So anyway, plug 0 and you get 3. So it starts here. Let's say it starts about right here, and it's going to be doing something like this. Okay, and there's a point on the graph when x is equal to 7, and we'll just say 7 is, we'll say 7's right here somewhere, and therefore its y value is going to be right here. Okay, and then there's a point in the plane 3, 2, so that's going to be somewhere about right here, we're just going to say. And they're talking about the rate of change of the distance changing with respect to time. Okay, so that'd be the fixed point here, and then we have this moving point that's moving along this curve right here, but when x is equal to 7, and of course they give us something else, they give us dx over dt, so moving in the x direction, which is actually 4 centimeters per second, right, moving in the x direction. We'll need to know about it moving in the y direction. We're going to need to know that, and we'll get that from this guy right here just by taking the derivative of this with respect to t. And you know what, we'll just do that right now. Dy over dt is equal to, so this is going to be 1/2, bring the 1/2 out front, and this becomes a negative 1/2, but we're going to go ahead and take it down here into the numerator and skip that step, and then the derivative of that 0. But once again, remember, we got to write dx over dt out here next to it. Now, right, okay. Um, and of course, we're going to need to get a value, and I guess I can just do that down here. We're going to continue this down here, if you don't mind. And so dy over dt, we're going to actually figure out what this is. So we just plug our numbers in right here, okay, and plugging in, we get 1/2, we get the square root of 7, because that's our x, and then dx over dt is 4. And this thing actually simplifies down to, let's see, it simplifies down to 2 over the square root of 7. Right. So dy over dt is 2 over the square root of 7. Okay. All right. We're talking about the distance changing between this point and here. So what we're going to be using is the distance formula. And I'm just going to go ahead and write that out right here. So we have x2 minus x of 1 squared plus y2 minus y1 squared. And then we're going to take the derivative of this thing with respect to t. So we do this implicitly. And we have a 2 out front. X of 2 minus x of 1. So these are just constants in here. And then dx over dt plus 2, and then y2 minus y1, and then dy over dt. Okay, we can multiply through by half all the way across to get rid of that 2's, get rid of those 2's. Now what we can do here is, of course, we want to solve for dd over dt, and I'm going to do that in this part here, but we're just going to go ahead and start plugging numbers in. So we're given x2, x of 1, y2, y of 1. Well, we weren't given actually x of 2, but we were given this guy, which is x of 1 right here. We're calling x of 1. And I should probably write out, write these numbers out. So this point here, which was something that they gave us, 3, 2, okay? And then this point right here, which is 7, and then the square root of 7 plus 3. Alright, that's going to be its y value. We get that by taking that and just plugging it into here. Alright. Okay, well, let's just go ahead and plug our numbers in now. Oh, I wasn't finished. Dx over dt, right, they gave us that, and then we found dy over dt down here. So all we have to do now is just simply plug the numbers in. So x of 2 minus x of 1. So this would be 7 minus 3. So 7 minus 3, and then dx over dt, which was 4, plus, and then we have y2 minus y1. So this becomes the square root of 7 plus 3 minus 2 times dy over dt, and dy over dt is 2 over the square root of 7. Okay, and this is all over d. Now d is, remember, the distance formula, right? And I am going to write it this time with the square root. So remember what the distance formula is: x of 2 minus x of 1 squared plus y2 minus y1 squared. So that's our distance formula there. So we're just going to go ahead and do that. And so remember, this was x of 2 minus x of 1, so we just rewrite this down here. And of course it's squared plus, and then this guy right here was our y2 minus y1. So that's going to be our square root of 7 plus 3 minus 2. Of course we can simplify that, right? And then squared. So there you go. You'll need to plug that into your calculator, or unless you're a masochist, you can work that out by hand with a pencil and a piece of paper. Yeah. Anyway, well, we should end up, once you plug this in, okay, and you might have to do it a couple times. It's good practice. And I'm going to write an approximation symbol here because we're approximating it, right, to 2 decimal places. And I'm trying to remember, but it came out to be like 3.4655, yada yada yada, but we're rounding it just to 2 decimal places. So this becomes 3.47 centimeters, right, per second. Almost said squared. Um, all right, and let's bring this up. Let me hit the answer here. Actually, 3.47 centimeters per second. Okay, so that was a little bit different from these others where the fixed point was the origin. We actually had some other point in the plane. So who knows what this could be used for? Maybe you're trying to set up a speed trap or something. I don't know. Anyway, but it's good practice. We're in this section right here, and remember, we're at gotomath.com. All right, see you there.